Hey, what's going on, folks? It's Mike here, and welcome to our first impression series in which we look at a programming language for about an hour or so and just get the first impressions. And today, I'm very excited to be presenting to you the language that we're going to be looking at, which is Kotlin. And Kotlin's a programming language that's been quite popular these days. And what I mean by that exactly is if we look at the TOB index here, which is some metric of programming languages, in which I'm recording this, well, Kotlin's on the rise. So I've been really curious and excited to check this out in this series to learn more about the Kotlin programming language. And let's go ahead and just dive in here. Let's see where its rank is. It's up from position 28 to 15. So quite a jump for whatever these metrics are as far as programming language popularity goes. But with that said, let's go ahead and start with the Wikipedia here for Kotlin and learn just a little bit more about this programming language. So Kotlin, from what I know and what we can find here, is supported and designed by JetBrains. So JetBrains has been known historically for their IDEs that they've developed, a lot of tools. They've done a lot of programming language research, including with Kotlin. So a really interesting place to be doing programming language development. They have a lot of experience building these tools, and building good software, or rather good programming languages, requires a good ecosystem. That's equally as important. So I think that's a really important factor perhaps in Kotlin's rise to power or use, or whatever you want to call it. Just the idea that it has and is supported with a really nice ecosystem from the folks who make IDEs like IntelliJ, CLine, and so on. So many of my students, many professionals I know use these tools. So again, JetBrains is a very well-known and reputed developer, at least in my eyes from what I have seen. So Kotlin itself is a relatively new programming language as far as programming languages are concerned. It's about 12 years old here, which again is relatively new or modern for programming languages. So it makes it kind of interesting because we've seen other languages like Swift, for instance, or even languages like V, for instance, which are relatively new and can really learn from some of the other programming languages that are out there, especially in the system space here. So Kotlin itself here, let's go ahead and zoom in just a little bit here, is described as a cross-platform, statically typed, general-purpose high-level programming language with type inference. Okay, so very interesting here. Statically typed languages seem to be winning out these days. It seems to be a good idea to have the type known and determined at compile time. So again, that seems to be the trend I'm seeing here. Again, it's high level in terms of, it's not assembly code, but I think this is sort of comparable to Java as far as the abstraction that you're working with. I don't think it's marketing itself as a systems programming language, although I'm sure there's systems level tasks that you can do here. But it's designed to basically work with the JVM. Okay, so it's sitting on top of a virtual machine here. So that means that we can pretty much get this right once, run everywhere sort of idea. And as you might know from the JVM, well, things like iPhone and, for instance, run native code. They're not built on top of Java like Android is, right? Android was famously choosing Java as its programming language when it was first announced here. But there is, on the first paragraph here, support for building native iOS applications. So I suppose in the compiler or somewhere in the ecosystem, it is just translating or maybe compiling or maybe just using the Java native interface to run native code on iOS. So that's pretty cool to hear, and also comforting if you're someone trying to get, again, Kotlin applications running on every possible platform. So I also like seeing this, again, this is sort of the trend, having multiple paradigms for your programming language. That means all the object-oriented stuff we've learned, functional stuff, and even concurrent stuff and generic programming, etc., are supported. Kind of interesting to see what sort of reflection support that they have. Many of the languages we've looked at, or if you followed my D series, we've seen some compile time reflection and cool things we can do. So I wonder, with Java being built on the JVM here, if we get some runtime reflection stuff here. So that might be kind of interesting to see here. Alrighty, so some other news and notes from the Wikipedia before we dive into the webpage. Google kind of is pushing here Kotlin programming as its preferred language for Android. So again, that sort of has this history of, again, Java was the default programming language for Android applications, but now we have Kotlin here. And that sort of makes sense if you have something as a developer and you want to do something native in iOS and Android, right? Write once and develop sort of everywhere. So I think that's really cool here. So since 2017, Android Studio 3, that's been the primary choice here from Google. And I've seen that. I just, again, haven't really dove into Kotlin here. And Kotlin, let's see, also has support for the web with Kotlin/JS, okay, through a classic interpreter-based backend. Oh, interesting here. Or it otherwise has an intermediate representation. I wonder if that's coming through like LLVM and WebAssembly or something, but that's kind of interesting. And then, okay, it's also got this Kotlin native, as mentioned, for Apple Silicon. So really cool and exciting stuff here. I'll let you read through the rest of the history here, although we should at least get the name here. Kotlin Island near St. Petersburg. Okay, so that's how the team got the name. Okay, so that's pretty cool. So just like how Java was named after the Indonesian island of Java. Okay, so just some fun stuff here. And again, as mentioned, JetBrains behind IntelliJ and so on. The ID powering this. Okay, so let's go to the official website though. Let's get some of the stuff. And of course, right from the start here, concise, cross-platform, and fun. Okay, so that's sort of what we want from modern programming language, the ability to use these tools effectively, make programming fun. That's hopefully why we're doing it. So if we go ahead to the Getting Started page here, this should give us the download. We'll actually run through this tour here. Let me just open that up in another tab here. And I have already started downloading this in the background when I started this video here. So it looks like I've already extracted that here. And let's see what we've got here. About 3.6 gigs here. That's giving us the full IDE. And we'll figure out how to install this. Maybe we'll start that in the background here. Let's open this up with Vim here. Okay, so we've got to unpack it. And then in our console, run idea.sh, run a little shell script here. Okay, let's see, where is that shell script? Open a console, cd into home, in the bin directory. Okay, it's going to initialize some configuration stuff. Okay, then we can add these things to our path. Okay, so hopefully it's just a matter of running that little shell script. We'll see if we need to do that as a super user or anything here. And let's just kick off that process here so that we can continue looking at the docs. Okay, let's see here. What else do we need here? Expected parameters, invalid args. Oops, I ran inspect, that's why. I want to do install here. /idea. There we go. Alrighty, so let's, that was quick. Okay, I guess it's already here. And you can see I've already been using this. Okay, my trial's expired by license. Let's just see what happens if we start another trial here. Okay, and I wonder if you can use Kotlin without the IDE as well. That'll be kind of interesting, but let's see what it gives us here. So we got to enter in our email address, and our trial has now started, apparently. Okay, so let's see here. Let's see if that did the trick. And let's see. Subscriptions active. Okay, let's activate our new license here. Let's see. Okay, got some code there. Hopefully you didn't copy all that down. Let's go ahead and begin. Okay, so you can see where I left off. I was doing some stuff with D in this a while ago. But we're going to want to do a new project here and do some Kotlin stuff, which is great. So let's see here. Now, immediately just looking at this, we'll get into Kotlin in a moment here. We've got our Java support. I mean, we've got the whole ecosystem here. And we probably are going to want to use Kotlin multi-platform here. But there's HTML stuff, React, and so on, Android. So that's kind of cool to see here. And let's see here. And we've got sort of what application we want to build here. Native. Okay, libraries, full stack web. Okay, interesting. Okay, so we'll dive into that in a little bit here, but let's continue our tour. I do like that it seemed to just run. There wasn't like a huge install or a shell script or something that could go wrong there. So that is nice so far. But just looking through the web page here, again, as mentioned, these are sort of the different applications. Interesting that they're highlighting data science here. There's a real interesting space right now for which language is sort of going to take over data science. I mean, is it going to continue to be Python? There's the Mojo language that came out recently. And then Kotlin is making its push here in November here, or perhaps even sooner. But again, supporting, notebooks. I mean, this is all cool stuff that we're seeing. So there are some plugins. Again, JetBrains being a big tool with the ecosystem, or rather a company that can provide an ecosystem for our language, right? If you can have notebooks where you can quickly prototype stuff. I mean, this seems pretty cool here to me. So that's really neat. So Jupyter Kotlin kernel. Yeah. Okay. So these are all things famous used in like Python with the Jupyter notebooks and stuff. There's Kotlin interpreter. Yeah, this is all very interesting stuff here. So just again, kind of looking at the language to see what it's got here. Kind of curious what it's got in all these tabs here. What's on the server side? Okay, some frameworks. I'm a little bit less familiar with these here, but it's cool to see what's being done here. Here's our Kotlin platform. Okay, so Android, iOS, web, desktop. Yeah, sort of the four things cross-platform. So again, super important. And again, most languages that can talk to C in some way or compile down to it effectively are cross-platform, or you can get things into iOS or Android through the Java native interface on Android, and then through Objective-C, like a little shim, to basically do the windowing stuff. Web could be a little bit more tricky if you have a language that doesn't output to, say, like JavaScript and compile down, or maybe WebAssembly. And the desktop, of course, most languages are going to be supporting here. So that's kind of cool here to see here. So let's see. I'll be kind of curious. I mean, maybe we'll see if we can do something in this video here, getting things set up here. But yeah, this is always one of the challenges, you know, and I've played around with Xcode, done a little bit of app development on that in Android Studio, supporting different form factors here. So I can see how they're doing that here. Seems nice. And they've got some, you know, real world companies here. Although I suppose VMware was just bought out. Anyways, so that's kind of cool to see here. Okay, what else did they got here? Let's see, some libraries. I mean, a big thing's going to be too, if you have a good standard library where you can just develop things. Again, they've got the ecosystem for this. They've basically got the whole, if it's built on top of the JVM, all those libraries, I suppose they could call into. Okay, they've got different ways to publish different variants. Okay, so this looks like some sort of build file. Okay, interesting. Again, Kotlin for Android. I mean, this is the sale here, so maybe let's pay attention to this. Why did Google, you know, adopt Android all of a sudden, or Kotlin for Android? Let's see. So since 2019 here, Kotlin first. Okay, interesting. So 50% of professional Android developers are using Kotlin. Wow, okay, down to only 30% according to some survey here. And they're saying it's making them more productive. Yeah, it makes sense. I mean, if you got a newer, more modern language with better tooling potentially, that should be the case. So, okay, we're going to learn about if Kotlin helps us prevent errors and these types of things. And okay, we've got all the ecosystem. I think the other big sell here is if you've got the Kotlin native. Now, I don't know when exactly that happened, but if you can develop once in Android and also get the iOS native stuff, that's a big win. Because otherwise, you're basically using like C, C++, and the native interfaces in Android and to iOS with Objective-C. And that can be a little bit tricky. That's not exactly a, you know, smooth experience. I've done a little bit of that, played around with that. Maybe we'll have some videos later, but that's the idea. Okay, so we'll get to the development shortly. Also like to see this Kotlin conf here. This is neat because, again, you always want to see that a programming language is growing. And conferences are a good, you know, evidence of that, to see that there's sort of yearly conferences and interesting things happening, as well as just active forums or other communities. So I always like to see that. You want to know a language is growing, or at least there's folks that can ask you for help. So that's pretty cool here. Alrighty, so anyways, enough on that. Let's see some of these examples here, and then we'll get started in the IDE. But, you know, just immediately look at this language. We've got our variables. This is kind of neat, just inlining them effectively inside of the string here. We've got range-based loops, and again, nicely printing things off here. Very cool. And we can run this, but we'll actually want to run these and try them out. Asynchronous. Okay, so this is kind of interesting to see coroutines here. They're going to have to play around with these a little bit to understand what's going on, but looks like they've got a scope block, which I do like this. That seems to be clear in the language what's going on here. This is a piece of code that can be suspended or can yield and then run. So effectively you get concurrency. Coroutines are a tool for that. And then we've got something outside here. I suppose that's just stopping or starting rather. And let's see, what's this doing? This is launching 10 concurrent tasks. Okay, so we saw something like this with Swift where they had tasks, right? I can't remember if they called them task pools or task groups, whatever it was. But that was the idea here. So yeah, this is kind of nice here. So I wonder if these are I'm assuming that these are the coroutines that we're launching, and these are the functions that can go concurrently or could yield or so on. Other languages call coroutines things like fibers, so you might see those. And we can run this here. Again, this is kind of neat here. All this stuff, by just being able to embed the code, this is almost like a shell script. I can see why folks say that this makes them more productive, because you don't have to like create a variable, assign it, do some weird string concatenation thing. You just embed it in the string here. So this is actually quite nice to just, effectively just compile this in here. That's pretty neat here. Okay, and it's doing the countdown, executing the workers. Let's see, I guess this is happening concurrently, synchronously, I guess asynchronously. Maybe it just happened in order here. Maybe I don't understand the example. What if we run this enough times if they execute out of order? I guess we've got a pretty simple job here anyways. Yeah, we see we're giving different workers. Interesting here. Okay. Object-oriented stuff here. Okay, we've got abstract classes and interfaces and classes. Interesting. So a lot of languages will usually have like an interface. I wonder if this is oh, interesting. So the interface, maybe you can provide some sort of implementation here and override it, maybe. Let's see here. So the restaurant customer is maybe implementing the food consumer interface where we overwrite eat. I guess we've got pay available, and then person, let's see, is also a part of this, and greet gets overridden too. Interesting. Okay, so we'll have to see the differences between abstract and interface. Again, maybe this is something more clear in Java. Usually interfaces are things that you implement. Abstract classes also must be implemented, but sometimes you can have like member variables. That's how some languages delineate from them, but neat. Okay, so look forward to that. Functional stuff, also good, right? They're doing a nice job showing off the multiple paradigms. Love seeing this, the chaining of functions. This just makes things clear. And then you've got things that tend to show up in functional languages, right? How to define a functional language, as we've looked at these, becomes less clear, but usually immutability, things like filter, map, reduce, show up in these sort of paradigms. Now this is kind of cool here. What do we have here? A data class here. I wonder if that's like a struct. Maybe that's what they're being explicit about here. I actually kind of like having different names for these things. Like struct versus class, or a record in Pascal is kind of nice because it just has like data or fields. That's kind of nice. And the type, but this is interesting. Data class, right? That's easy to search for in an IDE or something. But anyways, let's see here. We've got some messages, and it looks like you don't have to provide the constructor because it looks like these are just value types here. Okay, so interesting. And let's see here. Ideal for tests. Okay, cool. Let's see. Oh, I like this here. At test function, and then you've just got the tick marks here for the function name. I like that. Programming languages should probably just steal this idea. This seems like an optimal way. Again, if folks have been watching my YouTube know I'm a fan of D, which has built-in unit test. It would be nice if you could name them like this. And other languages, of course, have various frameworks that you can use. In more modern languages we're seeing, yeah, this was a good idea. To just actually, add in some tests here with backtick. So I really like that. And you can see the different assert equals, assert true, and so on. That seems very nice here. Okay, let's see what exactly is going on. Let's run this here. I want to see some tests pass. It's always a good sign. Yep. All right. So we got our test computation. Okay, interesting. So these are just running here. What is going on here? Or I guess if we're just running this and, okay, asserting that this works. Okay, interesting. Okay, so that's a pretty good tour of the homepage. Let's keep the docs open for us, although I suspect those will be on the tour. Yeah, nice to have a clean documentation page like this. You're highlighting some of the cool things like multi-platform development here. Yeah, it's a big sell if you tell me I can run native code on multiple platforms, or even on the JVM. Depending on what your performance needs are. optimizing things these days is getting really good. Let's go ahead and take the tour here. So that's this tab here. Well, this is kind of nice. Look at this organization. Maybe they talk to some education folks, right? Let's learn some concepts, practice, and then, well, we'll look to the solutions if we need to. Okay, so let's start. Let's just dive in here. Okay, and write our sort of hello world here. Maybe I'll run through a few of these fast, and then we'll see the language tour here, but we can kind of run some of these. Print line, I like it, same as in Java. Fun are keywords, so some languages like to identify those. Now there's no return type here. I wonder if that's just inferred for us. Interesting. Or maybe it just doesn't need one. That's okay. Anyways, print line, entry point, curly brace language, and then we've got print and print line here. And oops, I'm clicking around here, but this is actually a good thing to do here. I like all this LinkedIn documentation. This is really nice here. Okay, print and so on. Okay, great. This is looking nice here. Just look at the documentation here. Ooh, we've got an any type here. That's cool. All right, variables, read-only variables with val, and then mutable versions with var. Okay, so we've seen this in a few languages. Again, this is sort of the trend. I kind of like this. This is clearer than doing, all this stuff with like const int something or whatever. In more modern programming languages are getting smarter with just being able to infer, the type here, right? This is probably going to get inferred as an int or maybe a long type here and be immutable or read-only. Okay, so that's nice here. Okay, now again, we've got, okay, ways to declare variables, and they're said to be declared at the top level. Okay, these are global variables. They've got a little bit different notation. Okay, and then they're just showing off mutability there. Great. Let's actually see if we can, let's type out some of these so that we learn something here. Let's see here. Oh, I gotta close out everything here, whatever I was doing before. Let's close a project. And let's start a new project here. How do I do that? New project. Kotlin. Let's just do a console thing here. Just call this test Kotlin. And let's see, do I want Gradle or Kotlin Groovy? I don't really know the difference. I guess this is a JDK. I have 11. I thought there was Java like 20 something now, but anyways. Okay, let's go ahead and okay, let's see, 1.8 or yeah, I don't know, 11. And got JUnit here. Okay, let's just try this here. Let's just see if we can get a little hello world working. Oops, where did my Kotlin go? Okay, it's downloading stuff for me. Okay, so we'll let that get going here. Well, that's kind of nice, taking care of all the dependencies. Okay, so let's see here. It's useful to know how to print the contents of our variables. Okay, so we're going to use something known as string templates. Okay, so that's what we were seeing earlier here with these here. Okay, so that's cool. So here we're using template expressions to access data stored in variables. A string value is a sequence of characters in double quotes. Okay, template expressions always start with a $sign. Okay, cool. Yeah, this is much cleaner. I mean, actually learning something from a lot of shell scripting languages that do something like this, or even put like a little eval here. That seems to be the reasonable thing to do to me because, again, like I said, you don't have to create little variables up here. It's clear, escaping all your characters and stuff is kind of, it's a little bit ugly. And if you change the type and stuff, that can be a little bit nasty here. But yeah, this is kind of neat here. So maybe this is the default way to do things here. All right, let's see. This is still downloading, but we'll run some of these examples. We can see how they're working. Okay. Let's see on their exercises here. Okay. Complete the code to make a program print Mary is 20 years old. Okay, let's do it right in here. Print line here, and we say Mary is age years old. And look, no semicolons. That's like from Swift here. Let's see. Hey, did it on the first try here. Okay, so yeah, simple enough here. Yeah, I can see why folks are liking this and choosing this language for Android here. Let's see what the example solution was. Oh, I already messed this up. Maybe I wasn't, folks were yelling at me here. Name who will be, who shall not be named. Okay, anyways, there we go. All right, great. Let's take a look at the basic types here. Moving right along and trying to cruise through this so we can see what things are looking like here. But we got our basic types here. Okay. Kotlin was able to tell from our previous examples that int is our basic type, and Kotlin infers things, so type inference. I mean, this is the kind of stuff, it's modern today, but if you go back and read old textbooks, in like C or C++, you just never learn about these concepts. So it's kind of fun to, even if you're using like a language that's been around for a long time, which might be perfectly fine, it is nice to every once in a while learn some of these modern languages, learn some of the new ideas, some of these terms. Again, type inference is something that dynamic languages have, but a lot of these static languages, again, will just infer, yeah, this is probably an integer, right, or a long or some integral type. Now I wonder if we can force the type here, if we want this to be a char or something smaller to be a little bit more efficient, but let's see here. Okay, now they're showing us some operations here. They should look familiar to most folks here. Okay, here's our types here: byte, short, int, long, etc. Now I wonder if these are fixed width types here, meaning that an int is always 4 bytes. These things might not matter as much being on a virtual machine. The native code, right, when the assembly is generated, but in Java, I suppose that what virtual machine you're I guess executing on. So maybe that's true, maybe not. Let's see here. Let's see some more information on the basic types. Let's see, numbers. Okay, size. Okay, maybe this is giving us an exact size here. Although it doesn't say for sure. I mean, this is what C and C++ tables will tell you too, assuming a 32 or 64-bit architecture. Yeah, okay, not too big of a deal though for where we are right now in our journey, but maybe something. Okay, here we go. Number representation on the JVM. I mean, this is good documentation. I'm asking the questions and finding it, so that's great here. Okay. Okay, and then we have nullables. Nullable types here if you put a question mark on it, so it could hold a null value. Okay, yep. Yeah, this is another thing that we're seeing in languages here as they sort of evolve. Alrighty, let's kind of keep moving on here. Let's see if we got our IDE. It's still installing, maybe installing some things here. Did it pop up? Not yet. That's okay. Nice thing about this tour is we're able to move things right along. This answers my previous question here, where we can just explicitly tell what the type is here. So value and immutable int or read only here. Okay, so this is working just fine here. Okay, let's do some practice here. Explicitly declare the correct type for each variable here. Okay, so we're doing that with the colon afterwards. Okay, this is probably an int uppercase. Okay, let's see. Oh, I wasn't paying too much attention. Is there a string? Let's see here. Probably with a capital S. Let's see what I did here. B is never used. Okay, it's giving me warnings here, but that seems to be the right thing. Float. This is probably a long. Let's see here. Bool. And probably a char. Floating point literal. What did I see here? Oh, okay, so double then. Right, if I put an F after it, probably that's the case here. False. Lowercase? Or is it Boolean? Again, I guess I didn't pay as much attention as I should have. There we go. I actually like writing out the full Boolean. Let's see how we did on our test here. Yep, perfect. Now what if I had put F here? Does this make this a float here? Let's see. Oops. Whoa. Whatever that is, float. So let's see here. Okay, so it does have some suffixes there. Okay, great. Let's keep moving along. Collections. And they're moving us through this tour quite nicely here. Okay, so we got lists, sets, and maps here. Okay, so collections, containers, and other programming languages. So let's see. Let's play around with lists a little bit. Okay, let's see. To create a read-only list, use the list of function. Oh, that's interesting. This is something that I learned, again, just from looking at different programming languages. I kind of like this. I mean, this is telling me directly on the type that, this is a read-only list. It's a list of this. It's not going to change. Okay, so we don't have to worry about that in a statically typed language anyways. But it's, again, just telling me with the name of this thing what's going to happen. So I like that. And then mutable list, again, that's pretty explicit. This is a list of things that we can change. It's going to give us, some chunk of memory or whatever. I wonder if list of, well, let's click on this. I wonder if we can just, if it's small enough, I wonder if it stack allocates it. I mean, is it trying to do those types of optimizations? Can we get away with that if we're, if it's a read-only list? Maybe those are, I mean, there's no reason we couldn't do that with a mutable one either, but maybe that's enabling some interesting optimization or something. So that's kind of cool, right? If it's a small list. I suppose you could do that anyways. Okay, let's play with this here. Well, let's run it here. So I've got a list of these things. I just print it out. That's really clean here. Parentheses for initializing things. This is just a function call, I guess here, right? List of function, right? So it's some sort of factory here. Yep, telling us right there, there's a function. Variable number of arguments. Okay, so we got to see what the templates look like in this language. And then explicitly telling the type here. Now I wonder, where is it saying here? Did we just have val somewhere here? Just so I want to see if this is read only. Maybe it's inferring it. Oh, cool. We can see the source code here. So again, I like this. This is really well put together documentation. This is modern documentation here. Because then I can just actually, again, look at the source code. Okay, maybe we have to jump around a little bit here. I don't want to get us too lost, but this is kind of cool. This is a nice find. This is nice, again, because it's a type of thing where, you can kind of master the language. Eventually, you're going to get to the point in a language where you just need to be able to jump in the documentation and use it. Also really nice is this here. I can run an example. I wonder if every piece of code has an example. I mean, that's just great. Let's just click on some random things here and see if that's true. I mean, also to notice what it's supported on: Common, JVM, JavaScript, native. Again, very clear for developers. This takes a lot of effort putting this together. Okay, so we're mostly finding, okay, maybe not every function is documented, but that's cool. And I don't know, eventually you can get there. They've got a mechanism for it. All right, anyways, back on our journey here because we want to get to cool stuff eventually. But really impressed with the language so far. Mutable. Okay, so how do I add something? That's got to be in the next tutorial here. To prevent unwanted modifications. Okay, you could use read-only views of mutable lists. Yeah, this is another thing in programming languages that we're seeing to get mutable or views into data structures that are unmodifiable. But if you want to pass something into a function, like a huge list of something, but not modify it and have to worry about creating copies, you can do mutable list. Oh, you assign it to a list. Okay, interesting. Here's shapes. It's a mutable list, and then I say shapes locked. Okay, good name. Is just a list. Okay, so the list is like a view or something that's read only. Lists are ordered. Okay. Oh, interesting. Okay, they're ordered or contiguous. I wonder if that's what they mean by list. Okay, so I'll have to think about that, but they're showing me to get random access here. Okay, and then you got first or last. Oops, let's go back here to where we were. Okay, here we are. First or last. I wonder if it's implemented as a deck then. Something like that. Kind of an underrated data structure. I think that's what Python's lists are implemented as well. Double-ended queues, because you can get the first and last element easily and have random access. So kind of an underrated data structure. Or collection, I should say, since we're in Kotlin today. Okay, so we've got all these things like, count to check if something is in here. Let's just do a little bit of programming. And let's do number of elements in read-only shapes is, then we got to use our syntax here, read-only shapes.count. Let's modify these a little bit. 3. Okay, perfect. Adding or removing. Okay, we've got add or remove functions. You can explicitly just set the key here. Okay. Great. Okay, and then we've got sets, which are unordered. Okay, so it must be some sort of hash table data structure here. Again, same pattern, set of, mutable set. That seems consistent. Okay, good job. Okay, because they're unordered, yeah, you can't access stuff out of order. Okay, and then we've got maps, which store key value pairs. So again, like C++, we call that map, not to be confused with the map functional programming operations. I wonder what they use in here, if they use transform like in C++. Interesting. Okay, let's see here. Let's see how to use maps here. Map of apple to 100. Ooh, okay, this is something. Let's pay attention here. So you can access a value by referencing the key. You can imagine a map like a food menu. Okay, you have your key and then the food item, or the food item would be the key and the value would be the price. That's probably the way I'd rearrange those. Maps are useful if you want to look up a value without using a numbered index. Okay, yeah, and they're useful to just kind of stuff data in for many reasons. Okay, so same thing. Map of is read only, or map of returns a read only version of map. And then you got the mutable map of factory function there. Okay, so let's go ahead and see what's going on here. So we can create the map of, okay, so this is going to return us our read-only map, apple to 100, oh, kiwi to 190. Oh, interesting. So the to keyword is just explaining exactly this maps to this. Got it. Okay. Very nice, Kotlin. Very readable. Other languages will put a colon here or something, or you wrap these in, brackets or and form a pair or something. This is clean. That threw me off here. Maybe there's other ways to do this, but yeah, this is explicitly showing what's going on here. Great. So let's just keep running through this here on our maps. Nice here. Okay, so we got all the collections. Let's practice some stuff here. I'm going to ignore our IDE actually for now. Okay, I have a list of green numbers, a list of red numbers. Complete the code, print how many numbers are in total. Okay. Let's see. So let's just print the count of each of these here. Let's do green numbers dot count plus red numbers dot count. Okay. Yeah, let's wrap that string template, into one thing. What did I do here? Red numbers, green numbers, and use colon to separate expressions on the same line here. Interesting. Okay, what have I done here? Probably just misplaced my $sign. Oops. There we go. There would be mistakes, you knew that. And I'm off by a parentheses or something. Maybe that's a typical beginner mistake or something. Let's see here. What have I done? Take these. I mean, I could take these out and just say, oh, no, this has got to be, well, I wonder, I guess I can make this read only, total, and just do something like that here. Let's see. Oh, what have I done here? Missing expected. What's it expecting here? Too many arguments for public. Whatever. Here. Let's just print out the total that way. Does that work? 5. Okay. I'm assuming that's what we're supposed to get. Remember the count function or whatever. Yeah, okay, so something like that works. Okay, maybe some Kotlin Pro can, we can wrestle with that later. Okay, set of protocols. Okay, so it's just using the different sets and so on. I'm going to keep running through this, and then with, let's see if this is using, sets. Oh, that's the solution. I was going to say, where's the maps one here? Define a map that relates integer numbers from 1 to 3 to their corresponding spelling. Okay. Let's do this one here. Because I'm already forgetting the syntax for map of. Just going to copy this here. And let's see what we got here. So let's call this numbers map. Map of, it's going to be read only. And we want to do 1 to 1. 2 to 2. And 3 to 3. Alrighty. And let's see if we just print out the numbers map. That should give us what's it expecting here? This variable must either have a type annotation. Okay, so we got to say also, of course. So I guess I can't infer from this map here, the types here. That's interesting. Variable must either have a type annotation or be initialized. Map of. So let's see how we did that here. Now I feel like that looks okay. What did I change here that could be wrong here? Read only. Okay, we can check the keys here. Let's see. Oh, this is just an empty line here. Number 2 word. Well, I'm changing the problem a little bit here, but that's the idea. All right. Alrighty, so we got it. Let's take a look at control flow. Control flow, I might kind of move us through a little bit more quickly just so we can see some of the other stuff here. But we got conditionals, when statement. This is kind of new. I was expecting to fly through this, but Kotlin has surprised me once again. Let's see here. What we have. Object. Okay, so when object checks whether object is equal to 1, and then we print this, checks whether the object is equal to hello, otherwise prints. Interesting. That's pretty concise here. When can be used either as a statement or as an expression. Oh, interesting. So I guess each of these are the like conditions here. Let's actually do this. Let's modify it a little bit here so we learn a little bit of things here. Hello to print line, greeting to. That's kind of cool. Makes it pretty simple here to modify this code here. I actually like this as a keyword here, right? Instead of a switch statement, when. That's a little bit, that's pretty clear. So I wonder where this idea came from, or if this is a new thing in Kotlin or other programming languages have used this. That's the first time I've seen it, I believe. I was expecting this to be like the with statement here with like some object, but yeah, that's kind of cool here. Oops, let's go back here. Okay, and then, we can actually do assignment here. Interesting here. Let's see, is that what's going on here? Let's print line. Oh yeah, it's assigning the result here. So this is like a super, like I've seen this trick with ternary operators, right? Where you do something in other languages like int value equals, something like if true, then you do 1, or 2, something like that here. So this is basically a super powered way to do that. That's pretty cool. So I'm liking a lot of the different things that we can do in Kotlin. A lot of, again, convenience things. I can't really claim I like a language until I, dive into it for real projects, something at scale, maybe a few thousand lines of code at least to see how it is to maintain. But I mean, this is great stuff so far. Great. Okay, so some more conditions here. Now, are they pushing us towards pattern matching? Maybe. Let's see. That's another favorite feature from functional programmers. But this is pretty clean here for our conditionals. Was totally expecting to blow through this, as I mentioned. Okay, so let's take a look at ranges here. So I've got ranges. Okay, so there's different ways to define them. This is something, Pascal, for example, had these types of things, which are really nice. D has them. I like them. A lot of other programming languages have them. So very cool here. Okay, so for loops, yeah, I've got our range-based for. We could also, treat these as ranges. So that's really nice. Let's just go ahead and run this. Yep, just running through for every element here. And again, we tend to like range-based collections because we could iterate through things, shows our intent. We make sure that we're looking at everything. I wonder if we can lazily evaluate these. That would be kind of interesting here. Okay, so I'm going to go ahead and skip through this. Let's see what we can do with functions. And then get into classes and continue on here. Okay, so functions, we can return stuff. Functions without a return. Okay, they just don't have one. Okay. Let's see here. Single expression functions here. Okay, what does this mean here? They could be shortened. Okay, to something like this. Yeah, this is something D recently added, so I'm familiar with these. These actually come in quite handy when you are composing things, so another nice win. The other thing I'll point out here, depending on the programming language we've been looking at, the return type after the variable name. That seems to be more popular these days. I wonder if it allows you in Kotlin to put like x, y, z, int, because I really like that when I can do that. Okay, let's get into other stuff here. Okay, even more concise code. Yeah, Lambdas. Oh, cool. Yeah, this is the kind of stuff. Let's see here. Let's try to interpret this. Okay, uppercase. Okay, so string is the argument. That's what we're taking in here. And then we just run the function. Then return here. I guess it's inferring that return value. It should be able to. Okay, that's pretty clean here. Let's see if we can get a little bit more clarity here on the return type here. Yeah, they can be hard to understand, but they're just really concise. And lambdas are really useful when you want to be able to pass like functions as arguments to other functions and define different predicates. So that's often where I end up using them. Let's see what else they say about them. Yeah, you can assign a lambda to a variable and invoke it later. These things are also very useful when you have like user interfaces and stuff, or changing behavior of programs. I mean, these are super cool. Okay, so here's an example of assigning the lambda to this variable and then executing it with an actual string. Very cool. Passing to different functions like filter. Yep, this is exactly where you want to kind of use this stuff here. So here's a little lambda here. That's neat. It's just taking it here without parentheses, I guess, for this filter function. So again, kind of clean there. And again, we got the syntax just chaining these functions together. So again, very nice, very concise job here, Kotlin. And here's map, not to be confused with the map of data structure, but applying to each of these arguments here. You can substitute an x and multiply each of them by 2. So you can see how that's working there. And again, I really like map. It's just a clean way to, if you're doing some transformation on a loop, for instance, very nice here. Okay, function types here. Let's just keep moving along here. Invoke separately. Okay, what does this mean here? Lambda expressions can be invoked on their own by adding parentheses after the curly braces. Oh, interesting. So I can just write a lambda and then invoke it. Or I wonder if I assign it to some variable, then I just put a parentheses after it and it works. Okay, cool. Trailing lambdas. Let's see what we got here. Fold, and then yeah, lambdas after. Okay, cool. All good stuff here. Okay, let's see some of the object-oriented programming stuff and then keep moving our way through. I think we actually might make it through all the way of this part of the tour, and then we got to get to more interesting stuff. Classes, properties. Here's how to create an instance with our class here. Yeah, not too bad here. Accessing the properties, again, which is a nice way to refer to them as. Just dot, that's nice. I like languages, again, I'm coming from a C++ background frequently, so where you just don't have to think about whether you have dot or have to dereference something or whatever, it's just dot every time. Of course, that's going to be familiar in Java and JVM languages, most likely. Let's see here, many member functions. Data classes. Okay, let's unravel that mystery from earlier. Are useful for storing data. Same functionality as classes, but they come with, additional member functions. Okay. These member functions allow you to easily print the instance to a readable output, compare, copy, and more. Interesting. So you don't have to write all this boilerplate code, like your copy constructors and compares, maybe. Although maybe you do want to overwrite some of those things. Let's see. Oh, here's the default. Now, interesting. I wonder if we want to do a deep copy if we still have to overwrite that. Interesting here. Okay, so copying instances and so on. All right, let's get into null safety and then look at some of the other stuff here. This is the big one here, right? So we want to be able to prevent issues with null here, so we can make nullable types here. So basically saying like, you know, this type could be null or not. You know, this type can't be. It's some, you know, value type here. So that's good. That throws an error here. And this one could or couldn't be. Meaning that we can assign it to null. That's fine. We can check for this, which is good, right? We might have some data that's coming in that we have to wait for. So that's kind of interesting. And by default, it looks like, yeah, null values aren't accepted. Interesting. So you have to explicitly, let's see, I'm assuming you have to put a question mark after it or whatever. That's how we make it nullable. Yep, for the type. Okay. Okay, let's see what else we have. Use safe calls. Use a safe call operator. Oh, interesting here. Safe call operator. That's what they're calling this here. If the object property is null, this is useful if you want to avoid the presence of null here. Okay. Interesting. And then the Elvis operator. I think, was this similar in Rust here? Yeah, if you turn this on its sideways, I forget which language we were looking at that just had this. maybe it was Swift too. I'm losing track of these. Let's see. Okay. So if it is safe, basically you can print 0, I guess, if the length is 0. Let's see, in the following example, null string is null, so it's safe to call access to the length property, returns a null value. As a result, the Elvis operator returns 0. Okay, yep, so that's basically to say if this is null on this, then just push out a 0 or something. So this is another way that you could use error handling or whatever. Okay, well, it looks like we made it through the tour here. I want to look at some other stuff here. It's really interesting to see this language here. You know, there's WebAssembly. Okay, experimental, but you know, eventually I'm assuming this is going to be coming and keep improving. We've got native. Okay, and it's using LLVM backend. Okay, lots of different platforms. Oh, even great. You know, I was talking about at the start iOS for the native, but of course, yeah, Android NDK. So you could do both Windows, Linux, and so on. Okay, Kotlin for JavaScript. Interesting. Let's see some other concepts here. Let's see what else we got. Yeah, let's get into the asynchronous stuff just a little bit here. And the reflection, I do want to check those out before calling it a day. Because, yeah, let's see. We've got lots of different tools here. Let's see, how do we invoke a thread here? Okay. Prepare post. Is that what we have here? Okay. Good. Maybe this is a Java thing I'm not as familiar with. Or maybe this is like on a web post or something. Okay, yeah, that makes a request, blocks the main thread until it returns. Okay, so this is like an async call. Let's see, interesting. Like a blocking asynchronous call. What we do is launch in a separate thread. Okay. Okay, so they're just saying, yeah, threads aren't great. Okay, that's, yeah, we know that they're a little bit tricky to debug unless we keep it under control. Okay, with callbacks, the idea is pass one function as a parameter to another and have that one invoked once the process has completed. Okay, so we have some of these, yeah, prepare, post, okay, async. Okay, there we go. So this is going to do something asynchronously. Interesting. I wonder if there's like a pre and a post or what's going on here. Okay, yeah, we have the callback, you know, trouble, I'll call it. Okay, interesting here. Error handling is complicated, that's true. Futures, promises, and others. Yep, this is how we tried to improve on things. Okay, so you get this. Okay, so also, I mean, this is okay. You can run into interesting performance issues with promises. If they chain together, you can get synchronous code, which is problematic sometimes. That's okay. Yeah, I mean, this is still nice. I mean, this is what like JavaScript does. You can get some concurrency. I like how they're just giving the pros and cons here. Reactive extensions. Okay, cool. Everything is a stream and it's observable. Yeah, this is kind of cool here. I actually don't know too much about reactive Java, or even reactive JS React stuff, if that's what this is based off of. Okay, yeah, let's get into the coroutines though. Okay, because that's their approach. That's what it looks like they've leaned into. The idea of suspendable computations. Okay, so you could suspend and resume later on. So oftentimes you could suspend until like you need a result, for instance. C# I know you makes good use of coroutines. But it's, yeah, this is the main thing here. The benefit that when you're using coroutines, you're basically, when you're writing the non-blocking code, it basically looks the same. It just kind of fits in here. So yeah, you don't really have to think about it. And that's where threads get a little bit tricky. You have to think about like who's doing work or which threads to wait or where you're writing your data and so on. Okay, so it looks like we just get this launch here. And then when we execute, let's see here. So this code will launch a long-running operation without blocking the main thread. The prepare post function is what's called a suspendable function here. Okay, that's over here. That's the keyword suspend, prefixing it. Okay, interesting. Now I guess these are just function calls. Try to look in the documentation or something for them maybe later. What it means is that the function will execute, pause execution, resume at some point in time. Okay. Function signature is the same, just the suspend being added to it. Return type, however, is the type we want to be returned. Okay, which is this token thing here. Okay, interesting. Yeah, let's see the reference. Let's see what we got here. I want to look at the basics here. Let's write our first coroutine. or execute the example online at the least here. Okay, so we got this run our blocking code, launch a new coroutine, and continue. And this could give us hello. So, okay, so it should run this code. It's going to execute this in the background, print immediately, and then after the delay is finished, resume this execution. So we should get hello world most of the time, unless something goes really wrong here and this somehow takes more than a second. Now, of course, we could probably make that happen. Let's see if we do that here. If we execute enough times, maybe we'll get world hello. But let's see here. Is it... I guess it's going to launch here. Yeah, I don't know how to make it slower. Default... oh, it is in milliseconds, too. Okay, we get the idea here, though. Nice. So launch is a coroutine builder. It launches a new coroutine concurrently with the rest of the code and continues independently. Yeah. Coroutines tend to also be lighter weight, right? They're usually not full operating system threads. Now, again, I'm just learning about Kotlin, so I'm assuming that's what's true when supported. But yeah, let's kind of walk through that as well. Yeah, pretty nice. Allows coroutines to run. Okay, and then we have run blocking, which is also coroutine builder that bridges the non-coroutine world of your regular function. Okay, because let's see, if you remove or forget run blocking this code, you'll get an error on launch. Okay, let's actually see what that error is. If I just get rid of it here at the scope guards. Unresolved reference launch. Function delay should be called only from a coroutine. Okay, cool. Or another suspend function. Cool. Okay, so that overall makes sense to me. I mean, that's kind of cool. You get that almost like a type safety with the within Kotlin here, for making sure that again, you're writing basically code that is, I mean, it looks pretty synchronous to me, right? This is actually something, dare I say, JavaScript with their async await kind of does well. Again, you can run into some problems with it, but yeah, you're basically writing synchronous code. Now, of course, JavaScript basically has one thread, so you can kind of get into that stuff, but you can get some more performance effectively with that. But with these coroutines here, again, you're not really changing how you think about this code here. You're writing it effectively sequentially and saying, yeah, go off and do this somewhere else, and then, maybe we'll get blocked later or whatever, or have to yield this coroutine. if that's the right term in Kotlin or not, and then we can move along here. So that's kind of neat here. Structured concurrency. Yeah, this is like coroutines. So basically, you have those coroutine scope blocks here. Let me actually open that in a new tab. I guess this is the big thing to think about, like which platforms have that. So it's saying Android has it, which is nice. Cool. Yeah, structured concurrency is kind of coming back in a trend, right? We've been thinking threads forever, I think, in part because that's what our operating systems are sort of using. But now folks are revisiting this in modern languages, which is great. We're seeing coroutines being adapted. So there's been this sort of interesting life cycle. Okay, so I want to give a preview of that. I do want to check out reflection, and then we'll kind of terminate this video here. But let's just see what it's got here. Okay, so we've got the ability to introspect functions. Now, can we do this at runtime? Let's see, that's the question here. So on JVM platform, okay, we need some reflection features here. Okay, so we need to add a dependency. Okay, so maybe there's some runtime or something that can, we can add this in and understand what's going on here. Okay, yeah, getting the runtime reference to Kotlin class. Cool. You can just assign some value to some class here. That's cool. Okay. So function references. Yeah, we've got all this stuff kind of built in here. Okay, just wanted to take a quick peek at that. I guess it's got, if I scroll down enough, interop with Java reflection. So I'm assuming whatever you can do in Java, you can also do here. Prints public, yeah, so you can do these things at, basically it seems like do everything in Java, which you can do various compile time things, I'm assuming, but as well runtime things, at least with Java, I know you can do that. So that's kind of cool. I mean, you can like do some really interesting sort of meta programming stuff and so on. Alrighty, so we've looked at a lot of the platforms, the different support for that. We've seen some of the different collections here. We've got sequences, various transformations, lots of different libraries here. Okay, we've got some more tooling. Didn't get the IDE up and running, but I think that was okay because we got to give enough of a tour of the language here. So overall, I mean, quite impressed with Kotlin. It's a modern programming language. What else can I say? Since 2012, it seems to be very productive. I'd love to test it out. Maybe we'll do another video if folks are interested on doing like the multi-platform stuff or getting something running on Android or, that type of device here. Seems like a nice language. If the ecosystem is good, I can see why this language jumped from 28 to 15. It's gaining a lot of popularity. So anyways, folks, I hope you enjoyed that. Feel free to comment below on cool features I missed or if I made any mistakes here. I'm sure some of you are experts or have been using Kotlin, perhaps even in your day job or to build some of these multi-platform applications. I'd be really curious just to learn more as I am, about all these programming languages. So anyways, folks, with that said, thank you for your time and attention if you made it to the end of the video. Appreciate your support and feedback, and I'll look forward to seeing you in the next one.